Good evening. Now it's time for another lesson in writing linear equations. You've been introduced to the first form of the linear equation. That's really quite useful. It's the slope-intercept, which is y equals mx plus b. M is our slope, b is our y-intercept. The two forms that you're going to learn about tonight are the point-slope form and the standard form. First of all, the point-slope form. It is y minus y1 equals m times x minus x1. So what are this x1 and y1 I speak of? That is when you're given a point and you know the value of x and you know the value of y. So that's like a known point. And I'm going to show you an example of that in a few minutes. The next form is the standard form. And the standard form is not that it's useful when you're solving linear systems. Okay, so the standard form will be useful in later chapters, but I want you to see it now so when you're using it in later chapters, you won't be surprised by it. So it is ax plus by equals c. A, b, and c are coefficients, or just numbers in front of our variables. So let's take a look at some examples here. All right, let's say you are given the information. You want to put in point-slope form a line that goes through the point 1, 5 and has a slope of, say, 2. Okay, so let's put that in point-slope form. This is our x1, this is our y1, and this is our slope. So let's remember, excuse me, that it's x minus x1 times m, and that equals y minus y1. So let's just put this in point-slope form. I have y minus 5 equals 2 times x minus 1. And now we're done. Let's do another example. Let's say we have a line that goes through the point -3, -5, and it has a slope of 1/2. Putting this in point-slope form, what I need to do is I do y minus y1, so y minus -5 equals 1/2 times x minus -3. And I can simplify that because I've got these two negatives together here. Okay, I had to let the dog out. So let's simplify these. I can get rid of these minus and negatives and make this y plus 5 equals 1/2 times x plus 3. And there we have it in point-slope form. Okay, some more examples. What if I have a line that goes through 2 points, and my 2 points are 1, 5 and 4, 11. Okay, well, I'm going to say this is x1, y1. This is x2, y2. First thing I need to do is find my slope. Well, my slope is the change in y's over the change in x's. So if I do 11 minus 5 over 4 minus 1, I get 6 over 3, or 2. So now I have my slope, and I have 2 points. I have my x1, y1, my x2, y2. So I'm just going to do y minus y1, which is 5, equals 2 times x minus x1, which is 1. And now I'm done. Now let's say that I wanted to put this in slope-intercept form. I can do that because all this is all the algebra that we've already learned. We want to get y by itself, so we want it to be in the form y equals mx plus b. Okay, first thing, let's get rid of the parentheses over here on the right-hand side, and we'll do that by doing the distributive property. Remember that from chapter 3? So 2 times x, which is 2x, minus 2 times 1, which is 2. And on the left-hand side, I've got y minus 5. I'm not done yet because y is not by itself. So in order to get y by itself, I add 5 to both sides. They cancel. I get y equals 2x plus 3. And now it's in slope-intercept form. My slope is 2. My slope is 2. My pointer's not, or my thing's not working anymore. My slope is 2. My y-intercept is 3. Okay, the standard form. Now, let's say that I want to take this equation right here and put it in standard form. Well, standard form is when I have my x term and my y term on the left-hand side, and then the number all by itself. So what I need to do is I need to move my 2x from my right-hand side to my left-hand side. So let's go over here. Y equals 2x plus 3. Plus 3. So I want to move my 2x over. Right now I have positive 2x, so undoing that I do minus 2x on both sides. They cancel. I end up with negative 2x plus y equals 3. Now check it out. Here is one line in 3 different forms. I've got standard form, I've got slope-intercept form, and I've got point-slope form. So there are 3 different forms of the same linear equation. Let's see if I have anything else that I need to tell you. I don't think I do. Actually, yes, I do. So here I have standard form, and I have this equation, negative 2x plus y equals 3. Well, this equation could be written, as you know, in 3 different ways, these 3 different forms. I could also say that this equation is part of a family of equations. And the family is going to be this equation, the whole thing multiplied by any number. So let's say I want to multiply the whole equation by 5. So if I did that, I would do 5 times negative 2x plus y equals 3. And I have to multiply 5 by the whole thing. So I pretty much use the distributive property on the whole thing. So I do 5 times negative 2x, which is negative 10x, plus 5 times y, which is 5y, equals 5 times 3, which is 15. Now this equation right here, even though the numbers are different, is equivalent to this equation, and this equation, and this equation. Meaning, if I graphed any of these 4 equations, the line would all be the same. It would all fall on the line that has a y-intercept of 3. I got that from here, with a slope of 2. So I go up 2 over 1. These are all representations of the same line. All right, so I will see you in class.